This is Algebra 2 with trig. 3b.3a. We're going to solve rational equations using cross products. We can use cross products to solve rational equations when each side of the equation has a single rational expression. Many of us would call this a proportion. Right? These are proportions. These are the first time we've had an equal sign part of our rationals. We've been simplifying in the past. We have not solved. This here we will be solving. We will get x equals. And we need to be sure we don't have extraneous solutions. You must be sure that your solution fits the domain. Check to make sure your solution does not create a denominator of 0. That is the concern. Does your answer create a value of 0 in the denominator? That would be an extraneous solution, so we do not count that as a real answer. So to solve these, as it says, we're going to use cross products. Now, people make mistakes with cross products. They use it when there's a plus sign in between. We can only do this when there's an equal sign in between. We're going to cross multiply. What we're doing, we're multiplying x minus 2 to both sides, and that crosses off the x minus 2's on this side and leaves the 5. That brings the x minus 2 over with the 12. So we're going to have 12 times x minus 2. It gets crossed off on this side. We don't typically write it. We just do cross products. Then we're going to multiply 2x minus 2 to both sides of the equal sign. And essentially, cross products allows us to focus on 5 times 2x minus 2. Some of you might notice that this had a factor of 2 in it. We could have pulled that out, but that wasn't going to change our answers dramatically, so we could have reduced it, I guess, with the 12, but we're just fine. Distribute gives us 10x minus 10, and distribute gives us 12x minus 24. So notice that we only have one type of x. This is x to the first power. So we're going to isolate that x. We're going to get the x by itself. We're not going to bring everything over to the same side. We're not going to equal it to 0. So our 10x crosses out, our 24 crosses off. That leaves us with 14 equals 2x. And when we divide by 2, we get x equals 7. And if you plug your 7 back into the problem, you'll see that 7 minus 2 gives you 5. That's not 0, so you're okay. 2 times 7, that's 14. Minus 2 is not 0, so we're okay. So here we look at our denominators. We don't have any x's in these denominators. So we're not concerned about any number we get. We can't create extraneous solutions with this problem. So we get 15x, and we get 7 times 2x plus 2. I would suggest to take the time and write out that product. Because if you start to do too much in your head and distribute it incorrectly, you'll have more troubles. 15x equals 14x plus 14. Distribute that 7 to both values. Again, we only have one type of x, x to the first power. And we get x equals 14. And when you plug x equals 14 into here, you would have 14 divided by 7, which is 2. Over here, you'd have 28 plus 2, which is 30 over 15, which is 2. So 2 equals 2. You can check your work with solving equations. You'll know if your answers are right or not if you take the time to check them. This one's going to be a little bit different because when we cross multiply, look at what's going to happen. We're going to have x times 2x minus 3. So here we are stepping it up a notch and we are creating a quadratic. This gives us 5x plus 10. Here gives us the 2x squared minus 3x. Now, this case, we have two different types of x's. Here we have an x squared, and then we have x's. Two different types of x's, I call them. So this reminds us that we need to bring all the values over to the same side of the equal sign. We need to set this equal to 0. This gives us a quadratic. When we have a quadratic, we need to factor the quadratic. Now notice, the first step to factoring is there a GCF? Is there a number that can be removed to make the numbers a little bit easier? We can factor a 2 out of this. And by factoring a 2, we're just making the numbers a little bit easier to work with. We got to factor the 2 out at some point. So a quadratic is going to factor into two binomials. So we have x times x. That's going to create our x squared. 5 and 1 is going to multiply to be 5. It's the only way to multiply to be 5. Now you got to determine where your plus is and where your minus is. So you need more negatives. So it's got to be a negative 5 and a positive 1. Then you're going to do your zero product property. So this is x plus 1 equals 0. So x equals negative 1. X minus 5 equals 0. So x equals positive 5. And we got two answers. We check those answers back up in our denominator. A negative 1 gives us negative 2 minus 3. That's okay. A 5 gives us 10 minus 3. That's okay. So both of these answers work. So both of those are real solutions, and we circle them. We move on to our next one. You need to start thinking about what your first step's going to be. What do you see? What needs to be done? We're going to cross multiply. It's a proportion. It's two fractions that equal each other. So cross multiplying is how we go about solving it. So p squared minus 3p plus 2 times 1 gives us exactly that, equals negative 6 times p minus 1. Take the time to write the factors out like that. It'll just help you be sure you set it up correctly. Now, some of you might notice that this is factorable, but if we factored it, that would not help us here with this value. It could, but let's just experience an extraneous solution then and say negative 6p plus 6. when we have to bring them all over to the same side of the equal sign, that's p squared plus 3p minus 4. Now that's factorable. So we put in our parentheses. We're thinking about guess and check. We're not making a table. We're doing the calculations in our head. The first two numbers, when we think about FOIL, those have to be p and p. That creates p squared. The last two numbers, when we think about FOIL, have to create 4. Well, there's two different ways to do that. 2 and 2 and 4 and 1. 2 and 2 cannot add or subtract together to make 3. So it's going to be 4 and 1. They can make 3. I need a positive 4 and a negative 1 to add those two numbers together. Negative 1, positive 4 makes 3p. And multiplies to be negative 4. So the zero product property gives me a negative 4. The zero product property gives me a 1. Now notice, when you plug in negative 4 to the denominators, that works. Negative 4 minus 1 is 5, negative 5. When you plug in negative 4 here, you get 16 and then 12 and then 2. That doesn't give you 0. So negative 4 is going to work just fine. But 1, when you plug 1 in here, 1 minus 1 is 0. That's a denominator of 0. So we're going to put a light X through that answer and write the word extraneous solution right next to it. We only circle one answer. If this was a multiple choice question and it asked for the real solutions, you would only bubble in the answer of negative 4. We had a question like that on the final exam, and you could only bubble in one of the two apparent answers, because one of those was actually extraneous. It was not a real solution. Here we're going to get x times 2x minus 5, and we're going to get 3x minus 6, and x minus 2. So we'll distribute through to get 2x squared minus 5x. FOIL this out to get 3x squared. Negative 6 minus 6 more is negative 12x plus 12. So here again, I have two different types of x's. So I need to bring them all over to the same side of the equal sign. I get 0 equals x squared minus 7x plus 12. And that factors apart. So I know my first two numbers have to be x times x. My last two numbers have to multiply to be 12. It gets a little tricky. 1 times 12, 3 times 4, 2 times 6. But of course, what makes 7? 3 and 4 can make 7. A negative 3 and a negative 4 add to be negative 7 and multiply to be positive 12. So those are my two answers, and when I plug them into my denominators, neither one of those gives me 0. So those are my two answers. You can check to see if those are accurate by plugging your numbers back in for x to see if it makes the two fractions the same. You can verify your answers are correct. All right, these are a couple for you to try. So I would suggest to pause the video, work through these 3 questions. and then run the video, and you can come back and watch to see if you're setting these all up correctly. Good luck. So we're going to cross multiply 7 times x plus 2, 12 times x minus 3. So set up your products. Distribute through 7x plus 14, 12x minus 36, adding your like terms together, you got 50 equals 5x, and of course x is going to be 10, and 10 does not make the denominator 0. So that's my answer. Cross multiply. Distribute. Notice we do the same thing every time. When you know how to do one of these, you can do most all of them. Now we have 2 different types of x's. So that reminds us that we need to bring all our terms over to the same side of the equal sign. I notice that all of these numbers are even numbers. 2, 18, 16. So that tells me that I can pull a 2 out of it. I don't have to work with such big numbers. And it's a quadratic, so I'm going to factor it apart. X times x gives me x squared. Now, there's a couple different ways to multiply to be 8, but only one of those ways is going to add to be 9. It's got to be 8 and 1. A negative 8 and a negative 1 multiply to be positive 8, but add together to be negative 9. And your zero product property gives you 8 and gives you 1. And plugging it back into our original equation, notice this, that the 1 gives us 1 plus 1, which is 2. 2 goes into 4 twice. When we plug the 1 over here, we get 2 times 1 and 5 minus 4, which is 2 over 1, which is 2. So it completely works. And 8 doesn't make the denominator 0 either. So we would get 4/9. And here we'd get 16 over 36, which 4 goes into 16 4 times, goes into 36 9 times 4/9. So you can check your answers to be sure they're correct. Cross multiply. No need to say multiplies to 1. You just put x squared plus 4x. Distribute through. Two different types of x's, so I need to bring everything over to the same side. 0 equals x squared plus x minus 12. 3 and 4 can be a positive 4 with a negative 3. That's going to multiply to be a negative 12 and add to be 1. I get my 2 answers. And it looks like this one here is going to be an extraneous solution. Because it's going to make 0 in the denominator. It would make this side 0 also. 3 does not affect that. So 3 is my only answer. Now we look at a story problem. It costs a manufacturing company $50 to make a tennis racket. If the initial investment in the product line was $25,000, how many tennis rackets must be produced before the average cost falls to $75? So we're going to have $50 for every X. Let X equal number of rackets made. It's always good to define your variable so you know exactly what you're producing here. So $50 for every racket made plus the $25,000, that's the total cost that it is to make a racket. We want to find the average cost, so we're going to divide that by the number of rackets that are made. If it's only one racket, that's a very expensive price. But if we want this average cost to equal $75, we could solve for X to see what it would take for this to occur. Now, this only equals a number. We can make it a fraction by putting a 1 underneath it. So now we cross multiply, and we're only really need to cross multiply the one direction. And when we subtract the 50, we divide by 25, and we need to make 1,000 rackets so that our average cost would be $75.